When you take a shower, why does the shower curtain always billow inward and stick to you? This happens because the fast-flowing water from the shower head drives the air inside the curtain, creating a low-pressure area. The normal atmospheric pressure outside then pushes the curtain inward. This is known as Bernoulli's principle, the dancing raisins. If you drop a few raisins into a glass of soda water, they will first sink to the bottom, then float back up, and sink again, as if dancing. This occurs because carbon dioxide bubbles in the soda water attach to the surface of the raisins, acting like tiny balloons that lift them up. When the bubbles burst at the surface, the raisins sink back down. The slow honey race. Why does honey flow so slowly when poured, while water flows quickly? This is because honey has much greater internal friction than water. This property of a fluid-resisting flow is called viscosity. The Cartesian diver. Place a dropper with some air inside into a plastic bottle filled with water and seal the cap tightly. When you squeeze the bottle, the dropper sinks. When you release it, it floats back up. Squeezing the bottle increases the water pressure, forcing water into the dropper and increasing its weight, causing it to sink. This demonstrates the relationship between pressure and buoyancy. The cloud in a bottle. Add a few drops of alcohol to a plastic bottle, seal it with a cap, squeeze the bottle hard, and then suddenly release it. A cloud of white mist will appear inside. This happens because the sudden drop in pressure lowers the temperature, causing the alcohol vapor to condense into tiny droplets, forming a cloud. The self-siphoning water. Using a tube, you can transfer water from a cup at a higher level to one at a lower level, as long as the tube is initially filled with water. This works because the height difference between the two ends of the water column creates a pressure difference, and atmospheric pressure pushes the water from the higher cup through the tube. This is called the siphon effect. Oil and water don't mix. When you pour oil into water, they separate into two layers, with oil on top and water below. This is because their densities are different. Oil has a lower density than water, so it floats on the surface. Additionally, their molecular